All right, thank you for the heads up. Okay, cool. And with that background knowledge that we put together, the goal for me anyways would be that having sat down and written a number of pipelines myself from scratch, I would love it if somebody else tackling the same problem had an easier time. That's my dream. So let's kick things off. CI/CD is for me part of a group of definitions that exist in our field that are kind of very difficult to pin down and define with any sort of absolute certainty. I mean, like if you were to ask, 10 people what CI/CD was all about, you'd get probably 7 or 8 very different responses from them. And I think DevOps is kind of mixed in with this too. It's just as buzzwordy. You hear everybody talking about it. You ask them what it is. You get a really wide variety in responses as to what that is. Personally, when I've got a term like this where I keep getting bumped around, I keep hearing different things, I like to break things down into connotation and denotation. I'm not trying to confuse you further. I didn't know what either of those terms meant until I had to teach an ESL class about it. And 40 minutes before that class, I was like frantically studying to figure out what it was. Denotation is the dictionary definition of a term. It's the most bare bones. It's the most straightforward. It's the most limited. Connotation is like the other end of the spectrum. It's the widest possible meaning. It's all your personal associations with that term. It's all the episodes in your life you've had where that term has come up. Cultural context, workplace context, dealings with other people. The connotation of CI/CD would look something like this. It's pretty big. It's people. In your workplace, you probably have a DevOps guy. You probably have a platform team if it's a larger company. Maybe you don't. Maybe you have a guy on your team who's sort of the go-to for this kind of stuff. Maybe it's a smaller organization. You just have that guy who specializes in that. It's also tools. And we're technical people. For a lot of people, this is where the definition starts and ends. And there's nothing wrong with that. There's a lot of detail that's captured here, and CI/CD is implemented technically by a pipeline. Like you could think of a pipeline as a technical implementation of CI/CD. So the tooling does matter. Some folks would say, I'm doing DevOps with Firebase CLI. That's how we do it at my workplace. I'm doing CI/CD with Jenkins. There's nothing wrong with that answer, but I feel like it misses out on some related detail that might help us understand that big picture view a little bit better. There's also a very well documented set of practices, methodologies, habits, whatever you want to call them, but there is a massive amount of information floating out there on how to do CI/CD. And some of this material we're going to mine tonight, because I think there's a lot of gold there, especially if you're trying to figure out why things are the way they were on a dev team, or maybe you're just looking to improve as a developer, or maybe you're trying to achieve what I've been after, and that's that sort of big picture view of things. There's also the relationship between CI/CD and DevOps. Like I kind of alluded to the fact that DevOps is just as confusing as CI/CD. There's a lot of different ambiguous sort of definitions that are floating around out there. At this stage in my career, I find it very hard to believe that you could do anything DevOps-like without a solid foundation of CI/CD. Somebody explained it to me like if DevOps was a country, CI/CD would be like the capital city. And I was like, okay. I think of it more myself like if DevOps was a house you were building, CI/CD would be like the really solid concrete basement that you have to pour and really understand conceptually first before you can kind of proceed from there. And the last thing I have up here is frustration. And this is just from personal experience. Troubleshooting pipelines can be very tough. Troubleshooting pipeline configuration can be very tough. Sometimes the only way you can do it is to actually make commits to your code base and kind of just observe what happens, watch the logs. If you're lucky, you can log into your C environment and interact with it. But more than anything else, it takes time and it's not easy work. But that's a little bit of everything. So this is not a good place to start because it would be all over the place. Peeling it back to the denotation, the dictionary definition, we've just got 3 terms we need to define, and we can kind of unravel this thing. So the CD can stand for 2 things. I'm sure everybody already knows that. It can be continuous delivery or continuous deployment. And then we've got continuous integration. Let's tackle that first. Let's look at continuous integration. If you were to Google it, probably within the first 2 or 3 hits, you'd get an article by a guy named Martin Fowler. That's not an SEO trick. That's a really good read. We're going to use a lot of his article on continuous integration tonight as one of our main guides for sort of building that mental model or big picture view. You'd find a lot of references to the Agile Software Manifesto. That's also not a bad thing. It's a good document to read, and Martin Fowler is one of the authors of this document. If you go further, you do a little bit deeper digging, you'll find a lot of mention of a guy by the name of Kent Beck. Kent Beck gave us extreme programming and test-driven development. He's also an author of the Agile Software Manifesto. We're going to be referring to Kent Beck tonight as well. And you will not find any references to that 4th source I have on this slide, Heroku's 12-factor app. I'm pulling this in because I like it as a source. We're trying to achieve a big picture view. And one of the shortcomings of only looking at the first 3 sources is they all deal with the development portion of the SDLC, of the software development lifecycle. That loses sort of the color of the operations side of thing. Heroku's 12-factor app came out a few years before Docker. They were using Linux containers before they were sort of popularized by that platform. And they put together this document on how you should, design and run containerized code bases. But in a pre-Docker world, this wasn't a very interesting document, and people kind of lambasted it as saying like, oh, that's too vendor specific. In a post-Docker world, this document is a lot more interesting to look at. And regardless of whether or not you're using containers or not, it's changed conceptually the way people think about deploying software. It's given way to all kinds of like enhancements of terms like build immutability and a bunch of other things that it's sort of colored and touched. And it's changed simple things like how we think about environment variables. So I'm going to include it tonight. This is totally arbitrary, and kind of wear your critical thinking hat, make up your mind for yourself as to whether or not you really feel it's relevant. But I do think it offers something in the way of complementing the other sources. And then I did promise you a dictionary definition. This is super not interesting. But integration in this sense, continuous integration. Integration here just means merging code. So continuous integration would just be merging code continually. It's a pretty straightforward definition. And if you're working by yourself, it's really easy. You just, you make a commit and you push it, and there's not really much else to talk about. It's pretty straightforward. This all becomes a problem when you're trying to collaborate and cooperate with other people. And things not only get complicated, but they get complicated fast. And one of the great things about that article Martin Fowler put together is that he defines the problem. And again, before rushing out to sit down and hammer out a pipeline implementation, it really helps if you understand the problem first. So Mr. Fowler describes the problem as integration hell. And if you go back 10 years ago, this was like a huge meme. It was, very, very popular term. Merge hell was an alternative version of the same thing, but it's describing this event that would happen when you have a software development team. They're all, maybe you have 6 or 7 developers. They've all gone off to work on their features. And then the product manager or the project manager rings a bell and says, hey guys, we got to get a release together. Everyone comes back with their finished features, and it's some poor schmuck's job to combine everything together into a release. And this was called integration hell. Well, why is it hell? Well, you get merge conflicts. You wouldn't be able to build the project because there's dependencies that are missing, maybe some JavaScript libraries, maybe some operating system level dependencies. You can't get anything to work. There's configuration file or data that's not in the code base. It must be on somebody's machine. I guess we'll go looking for it. There's duplication of code. This is You'd have to be really paying attention to notice this, but if you think about it, if you have a bunch of developers who are all working on the same problem domain, there's a very good chance that they're going to require helper functions, for example. And if they're off working on their own, there's an even higher chance here that they're going to implement those helper functions separately. They're going to implement the same helper functions. And in fact, they're probably going to do a ton of duplication. This would also happen, and it's a little bit more insidious, but with business logic. A really silly example of this would be maybe we're going to sit down and write an app that estimates the cost of a load of laundry. And you would need to know the rate of hydro in order to make that happen. So let's pretend it's a fixed rate. And you have developer A and developer B, and they both go off to work on this. If they both embed that constant in different places in the code base, you've just created a single source of truth problem. That it's a problem because if the rate of hydro ever changes and you find one of those constants and you update it, but you don't update the other one, your app is suddenly not accurate anymore. You have to spot that when you're doing this integration. It's incredibly important. But of course, if you're working by yourself, this is not a big deal. Like you've got everything under control. You can manage all of this. It's only when you're working with other people that this becomes a problem. And if you were to Google integration hell or merge hell, you'd find a lot of references to this thing called like the synchronization problem. It's kind of like a metaphor that people use to sort of conceptually understand it. But it goes something like this. You have developer A, developer B. They're going to go both work on features for a problem domain that they're both working on. They go away, they spend X amount of time working on their features. They come back. Well, now they have to spend like 2X or 3X amount of time explaining to each other, how the code works that they just wrote. But they also probably learned a bunch of things about the problem domain that they were working on, maybe business rules, maybe something about the framework that they're using. They've got to exchange that knowledge now too. Time is in short supply on a development team. This is a valuable resource that they're now consuming. It's probably why communications is like such a buzzword in DevOps. It's on anything DevOps you read, you'll see communications all over the place. It's also a central tenet of extreme programming. It's also one of the core principles of Agile. A lot of this is all about constructing that. I just have on the slide here team mindset, but it's maybe more described as like an awareness. You have a particular change set that's in front of you that you're responsible for, that you're working on, and you could focus your entire attention to that. But it really helps if you can elevate your consciousness or elevate your awareness to understand how what you're doing affects everybody else and how it, what are the implications for what you're doing and the changes that you're making, and how does that affect the whole team? And building that kind of perspective, that's really useful. And unfortunately, you don't get a lot of opportunities to do that as a solo developer, but you can, if you're not yet on a team, this is something that you can definitely start thinking through as you work. So how do we solve integration hell? Like, how do we fix that really awful problem that we just discussed? As I alluded to earlier, we have some guides. In his article, Martin Fowler has 11 concrete principles that we can follow that pretty much solve the problem completely. The article is 15 years old. That might sound ridiculous, but as we go through it tonight, I'm really hoping you see how relevant it still is and how it's shaped a lot of the ways that software development teams work today. Kent Beck's feedback loops is something that I'm going to pull in. Feedback loops are like very prominent in DevOps literature. They're also very prominent in they're prominent in Agile. They're prominent. They're the cornerstone of extreme programming, and they're a big part of test-driven development as well. We'll talk about those as well. And then I'm also going to pull in Heroku's 12-factor app, kind of my oddball source, where needed to sort of reinforce what Martin Fowler is saying. So as we proceed here, we're going to start a little slow. The first 2 or 3 of his practices deal with build automation. After that, we start thinking about how we can change the way we work every day to sort of improve our efficiency and spot problems with continuous integration, spot problems, pardon me, with integration hell before they become a problem. Once we get past that point, we're sort of at the midway. We're going to start talking about some actual technical tips that we can use in our pipeline optimization process and our pipeline design process. And as we close in towards the end, it's about reinforcing open communication. And then finally, we're going to ship some code. So let's kick it off. In practice number 1, Martin Fowler advocates maintaining a single source repository. Well, he's talking about using source control, and that's just a grant. We just take that for granted now. That's just a given in today's day and age. But what isn't always a given is ensuring that you include everything in your code base that's needed to set yourself up for build automation. He's very explicit about this. He's talking about the 2 levels of dependencies that you want to absolutely make sure are present in your code base. The first is the language level dependencies, and this is kind of a solved problem. We know if you're JavaScript people, you check in your package.json file, you make sure it's in the code base. You don't manage libraries by saying, hey Joe, if you install this library, the project will work. That's totally not scalable. How are you going to automate that? We don't manage things ad hoc like that. We have a solution for it. We have that package.json file. We check it in. If you're a Python developer, you check in your requirements.txt file. There's a solution for this in every modern language now. He also refers to the OS level dependencies. This is where things aren't so obvious. This is anything you would install with brew, apt-get, a package, yum, whatever your package manager is. You're going to need all that stuff to make your project work. Silly example, Git. If you're going to do some build automation on another machine, you're probably going to need Git present so that you can clone the project and probably run some other commands. You're going to need Git. Git is a dependency for your project if you're using Git for source control. That kind of statement of the obvious, though, is something that we can run past sometimes. It's also why probably Docker became such a popular solution, because it formalizes this process of capturing all those dependencies in the code base, right? Another way to do it is like scripts. You can also do this in your pipeline config files. There's a number of avenues available to us now, but the main point is set yourself up for build automation by not leaving anything to chance and including everything in finite detail that you need to make your project work. It's also really nice to have all that in place when you join a new dev team, so you're not running around like a maniac asking people 100 questions when you're trying to build the app on the first day. As a complement to Martin Fowler's article, I do want to pull in the 12-factor app here. They talk about code base and dependencies too, but where it gets really interesting for me is factor 3 config. Martin Fowler tells us what we absolutely need to include in the code base other than just our code. The 12-factor app says, well, hang on just a second. There's some things that you don't want to put in your code base. And it elaborates by saying config, or you call it settings, call it whatever you want, but there are some things that are determined by the environment. They are not determined by, they're not 100% true all the time. Well, what's an example of that? A password. A password for your database. The password you use for your database in local production is, of course, different than the one that you use in production. In your local development machine versus production. Why would we change that? Well, there's obvious security ramifications for that. How do we manage that? Well, we also know the answer to this already too. We use environment variables. Things that are environment specific, we manage with environment variables. We want to keep our code base portable. It's nice that we've set ourselves up for build automation, but this is not like a static thing that's going to run in the same place all the time. You want to use environment variables. You want to refer to things with process.env to give your code base the ability to live in different places. And an area where you might not think about this immediately is things like host names. Redis is found, in local development, it's found at localhost. In production, it's not localhost. It's probably a dedicated server out there somewhere. You want to keep your code base flexible. You want to build in that ability to let it grow in different places. You want to use environment variables for that stuff. We take all that for granted now, but you can kind of see how the two sources kind of come together here to tell us how to structure our code base to set ourselves up for build automation. Okay, let's automate the build. Okay, well, we're going to probably need some scripting to pull that off. I'm still, you might hear some groans out there, but Bash or basic shell scripting is still incredibly useful to have under your belt before you tackle anything sort of pipeline related. And I know we have all kinds of cool modules, and we know we have GitHub Actions. We have all that great stuff now. You can still get an incredible amount of mileage out of shell scripting, particularly when it comes to doing silly stuff. But like just manipulating environment variables in itself can save you so much time when you're trying to get a pipeline cobbled together. It's incredibly useful. I have up here on the slide a really silly example, but of a script that I've put together that builds a React app. It installs Git, my only OS level dependency. I probably should install Node too, but I guess this script is like assuming that Node is present. You know, I clone the code base, I run npm install, and then I run the build command. Pretty straightforward, but it's this type of thinking that Martin Fowler is advocating in the step here. He's like, look, you got to go back to basics and you got to break things down. You want to create a repeatable process that you can use every day, repeatedly, to get the same result. Why is that important? Why is the repeatedly repeated so important? Well, the goal is a validated build. Well, if we're doing this thing all the time to our code base and suddenly that thing that we're doing all the time stops working, well, there's a problem. We should investigate it. That's why the 12-factor app has in factor 5 a step called build, release, and run. We're talking about deployment for a second. We're just going to make a little segue here. But if you were to structure your deploy process so that you had you set up a server and you were going to clone the project on that server, you were going to build the project on that server, and then you're going to start your project, that would not be a great way to structure your deploy process. And the reason for that is if the build were to fail, your SOL, and you have a server running that has nothing on it. You have a cloned code base. That's all you were able to achieve. You want to separate your build from your run so that you can do this validation that the build is okay, the code base is okay, things are okay, and only under that, only under a pass from that scenario would you want to actually kick things off and start running something. So this idea of a validated build is like a really important sort of underlying necessity to sort of make CI work as a thing, to make continuous integration work as a thing. On top of all of this, before you actually jump in and write scripts or jump in and write YAML for your pipeline configuration, you want to have a really good idea of how whatever framework or library you're using handles environment variables. Again, I've gone on about them at some length, I guess, but there's a reason. Every CI tool you use will implement this, and they will all implement it differently. You want to be sure that you understand how that works. But there's also complexity involved at the framework level for how this kind of thing is dealt with. Remember, you want to keep your code base portable. You want to build that into whatever project you're working on, so you can run it at different locations. So, React has a way of managing this built right into its sort of bare bones templates. Next.js as well. I'm not as familiar with other JavaScript frameworks, but other ones I've used like Django, they have a particular way they like to deal with that as well. And you want to know what that methodology is before you get into this stuff, right? And then if you're not ready to sit down and write scripts or anything like that, that's okay. Just document what you find. Break down the build into all the steps you can think of and document that. Again, if you have somebody new joining the team, that's like a lifesaver if it's like your first day and you're trying to get things to work. So next in practice 3, Fowler sort of builds on to that idea of a validated build. He extends it further. How? Well, he wants us to make our build self-testing, and he's referring to good old-fashioned software testing. This is all the stuff that we're already familiar with: unit tests, integration tests, you know, bread and butter software testing. It kind of helps though here to pull Kent Beck's feedback loops in, and we kind of mentioned that earlier. Feedback loop is not this super difficult concept to get. It's pretty straightforward. It's just this idea of like, whenever you take an action, you get a response that tells you, am I on the right course? Do I have to course correct? Is everything okay? Is it not okay? It's kind of like a thumbs up or a thumbs down that you get back from the system that tells you, is what I'm doing okay, or do I need to do something else? That's a feedback loop. From a testing perspective, well, a test is a feedback loop. You make a change to your code base and you get a green response or a red response. You know whether or not things are working or if they're not working. It's very simple. But automated testing prevents integration hell directly. Well, how does it do that? Well, imagine I'm working with somebody else. I write tests for my work. My colleague makes some changes to their code, and suddenly my tests are going red. Well, that's a conflict. That's a conflict between his changes and mine, but that's not a big deal at all. That's not turning into some massive like thing that's going to make the whole project late. That's not turning into some like dire emergency when everybody's trying to scramble at the last minute and pull software together. It's not a big deal at all. It's just like a broken test. He's going to fix it. It heads it off before it's ever a problem. And if you think about Agile, this fits really well with Agile. This fits really well with that idea of small iterative steps. You write some code, the code breaks. The code breaks the test. You make a change, you fix the test, you carry on. With Agile, your team builds a skateboard and gives it to the customer, and they're like, great, I can get around now. They come back a week later and they're like, you know what, I'm tired of standing all the time. Can you do something about that? You build a bicycle. They come back a week later and they're like, we're tired of pedaling around. You give them a motorcycle and they complain again, you know, this is just too dangerous. So they finally get the car that they've been looking for. And that sort of inherent feedback and small step taking is built right into the fabric of Agile as well. And it's a core concept of how continuous integration works also. And testing is the building blocks of that. And on top of that, if you think about deploys, we're going to do some, we're going to do any kind of automation that deals with deploys. It sounds, to be frank, it sounds a little foolhardy to like automate deploying anything that you're not doing at least some kind of testing on. Testing in this context just sounds sort of like sensible risk management. It sounds like just something you would want to get in front of. And, you know, all of this being said, if you're not testing your software, or testing is something that you're like by itself, you're intimidated by testing, that's totally like understandable. I think like I never really became, I don't think I ever really became a competent developer until like I knew my way around testing. And even now, I still feel like there's so much to learn. But I think it's a good thing. If that's like something that you're not comfortable with right now, I think you've identified like a really good area where you could work on and potentially become a much better developer. At least that's my take on it. I wouldn't be put off by any of this though. But just keep that notion of feedback loops in the back of your mind as we just kind of proceed here. In practice number 4, we get into kind of some of that stuff I talked about earlier, where we're going to change the way we work every day. In practice number 4, Fowler is advocating everyone commits to mainline every day. And mainline in this sense means like trunk or master or main or whatever the central branch is. And I think this is best explained by the quote from Kent Beck that's on the top right there. Kent Beck says, if you integrate throughout the project in small amounts, You will not find yourself trying to integrate the system for weeks at the project's end while the deadline slips by. So we talked about that dictionary definition, merging code continually. This is where it gets implemented. So you do that really awful hard thing, but you do it like at a less intense pace, and you kind of just do it all the time, and it just sort of turns into a little bit of a background nuisance. It's not a big deal anymore. In practice, there are two implementations of this recommendation from Martin Fowler. There's kind of two approaches that have emerged as being popular. The first is trunk-based development, which I haven't got a chance to try myself yet. It's often put together with pair programming. It's where you basically, whatever feature set that you're trying to pull off, everybody breaks their work down into really, really small parts, and you constantly make small commits to master, main, or trunk, and everybody shares master, main, and trunk, and you make commits right to it all day long. This, if you haven't tried it before, it sounds super scary, but because you can't really do code reviews in that environment, but that's why it's put with pair programming. So you're working with someone who's like actively reviewing your code and like challenging you on what you're doing as you sort of go. And I've done a lot of pair programming. It's pretty fun. But if you think about the synchronization problem, it sort of changes this whole approach of like big, massive changes that you're dumping on someone into small, little, constant streams of changes that we're making like throughout the course of a workday. Again, taking like big, massive changes and breaking it down into small pieces. Potentially more popular approach to this is the idea of short-lived feature branches. Probably, I bet you're all familiar with this. The shorter the better, of course, right? If you cut a branch to do some feature work, and that branch ends up lasting like 2 weeks, 3 weeks, whatever, you're just recreating integration hell. Like you did all that hard work, all the stuff that we have already talked about, and you kind of pull everything back, and you basically just recreate the problem that you were there trying to stop in the first place. It still requires you to like break things apart into smaller pieces and structure your work in such a way. But you're doing code reviews in this sort of like, you're doing active code reviews in this sort of like setup. So you want to have some kind of empathy for the person who's going to review your code. You don't want to slam them with big changes, and you don't want to bring your whole team back to integration hell. So you don't make commits that touch like every file, right? And that sort of evolved into the next practice that Fowler's advocating. And this is the idea of, and we totally take this for granted now, but every commit should build mainline on an integration machine. And the technology has advanced too. We don't build just mainline anymore. We don't just build trunk or whatever. We build everything. Any commit that gets pushed to any one of these CI services that we're integrating with, we build everything now. But if you think about it from a feedback loop perspective, this starts to get really interesting, because in his article, Fowler describes this as monitoring for your code base. And that kind of made me go, oh, cool. I've done a lot of systems kind of stuff. Like I've spent my fair share of time with Nagios or Sensu or some of these tools, logging into servers, trying to figure out what's going on. But now you've got monitoring for your code base. That's pretty cool. That is a cool way to think about it. Every commit now triggers a feedback loop, and you get that validation as to whether or not you're on the right track or something's going wrong. So you're constantly being steered away from doing something that would bring the team towards integration hell. It's kind of neat. He differentiates between this and timed or cron builds, though. You could think of, there used to be this thing called nightly builds that teams would do, where they would like build the project overnight. So you would come in the morning, you'd have like a fresh build to work with. Or you have like periodic, like weekly builds, which still have their use. But he says that these are not code-based monitoring, right? It's not frequent enough for code-based monitoring. It's not triggering the same kind of feedback loop. And that makes sense. But timed or cron builds are still useful. the best example that I can think of right away is like package vulnerability scanning. If you put npm audit into your pipeline, and then you add that pipeline to a code base that you're not actively developing anymore. Maybe you're like maybe you're starting out in your career and you're just doing like some demo websites, right? And 6 months go by and you come back to that project, it's just riddled with vulnerabilities. You can't even get it to build anymore. Well, what you could do is set up like a weekly build on that project where you would check for vulnerabilities. And, if something came up, you would get notified, maybe here or there to go and take a look and update something. This is a very useful use for timed cron builds, but it's not really continuous integration. It's kind of a different purpose. So building on this a little bit further in practice number 6, he kind of just says, respect the feedback loops that you set up. You did all that hard work to give yourself like these great insights that sort of keep your team on track as you work. Don't ignore it. If you ignore it, you risk falling on the wrong path and heading right back to where we started. Kent Beck says, nobody has a higher priority task than fixing the build. If you were to think about trunk-based development where people are sharing a branch and they're actively working on it together, that's particularly true. I mean, if you break the build, if you break master, you're kind of blinding everybody. Everybody's without the feedback loop now. But Martin Fowler's very straight to the point with saying right away, this is going to happen. Broken builds are not a big deal. They are going to happen all the time. It's how your team responds to them that's really important. Yeah, you just don't want to fly blind for extended periods of time. You don't throw away all the hard work that you've done. In the Pragmatic Programmer, he talks about, there's a chapter where they talk about fixing broken windows as like a metaphor for apathy, and how, when you see somebody else ignore something, you kind of fall into the same pattern, and you sort of subconsciously register that, oh, I guess it isn't very important. They don't care about it either. And you kind of want to route that kind of apathy and don't let it set in. But more than anything else, it's just about respecting that feedback loop that you've set up and making sure that you're harnessing it for its sort of full potential. And along the same lines, he says in practice number 7 that you want to keep your builds fast. And that makes sense, right? If it takes 2 hours to get some sort of like response from your feedback loop as to whether or not things are proceeding okay or not, it's not very useful anymore. Slow builds kill momentum. I think that's the way he sort of summarized it. Extreme programming gives us a number. Extreme programming says, 10 minutes, cap your build at 10 minutes. If it's more than 10 minutes, that's too long. But I think like in today's day and age, 10 minutes is like easily exceeded. Like it's not a problem to keep builds fast anymore. But if you did get into a scenario where you did have to optimize something, you should know what you're getting into way ahead of time. Definitely measure. Like any other type of optimization that you're going to make, look at your timings, figure out what's taking up the bulk of the build time, and zero in your efforts on that. Writing good tests is an art form. Writing good fast tests is like a rare art form. It's like it's definitely a goal to shoot for, but you get as close as you can. But the more knowledge you have of Bash software testing, the more knowledge you have of your CI tool, the more tricks you'll be able to pull out of your pocket to sort of speed things up. And speaking about tricks, one of the great low-hanging fruits that's available to us with any sort of background knowledge of Bash or any sort of background knowledge of any CI tool, because they all support this now, but you can make steps concurrent. So you want to look for opportunities to parallelize your pipeline code where it's appropriate. And that can be a quick win for speeding things up if you're in a bad spot. This is like a really silly example of that, but it illustrates the point. So at the top, I have a sort of like improved version of my original web app script that's installing my React app. And it's doing the same things. It's installing Git, it's cloning the repo, It's running npm install. And then it runs, the test suite. It does package audit, and then it builds the app. But the cool thing is that once you've run npm install, once you've installed the JavaScript dependencies and the OS level dependencies and the code base, once you've taken care of the basics, everything else can be run concurrently. So you don't have to wait for one to finish. Like my pipelines to pass now if those 3 concurrent tasks all pass. And you want to look for opportunities to use this. You want to be aware of the limitations of whatever pipeline system is put in place. You want to, like, if you've got an in-house Jenkins system, you definitely want to know like how many machines are involved in the build process, like what kind of resources are available. Are there any sort of like, detrimental cost problems that come up if you do something like this? All of that being said, though, 9 out of 10 times, this is a quick way to speed up your build. It's definitely something to keep in your back pocket. So in practice number 8, Fowler advocates testing in a clone of the production environment. And I think a lot of this is like protecting your investment. What do I mean by that? We've gone to all that work to automate the build. We're now building on every commit to the code base. We've got all this great meaningful feedback from like whether our tests pass, from whether the build passes. We've got all this great stuff. We're really humming along now. We're making progress. We don't want to jeopardize that by introducing like unknown factors that we're not accounting for. The best analogy I could think of is like cross-browser testing. Like, ahead of time that you've got users who are not going to be using Chrome. They might use, Firefox, Opera, or something else. You're aware of that unknown, so you account for it. You do additional testing to cover yourself off for that scenario, right? You don't want to like take shortcuts somewhere else and introduce like more unknowns into your system if you can prevent it. And a good example would be you might be running Postgres 9.2 in your local dev environment. And you might be running, 11 something in your CI environment, and you might be running 9.4 in production. And you're probably going to be okay. Like let's face it, that's probably not a huge problem. There's probably nothing that's going to happen as a consequence to that. But it's really not that hard to make those line up. It's not a lot of extra work. Wouldn't it be more sensible to sort of protect your investment and just make them the same? This kind of risk management is what he's getting at here. And in fact, the 12-factor app says the same thing. They say the same thing in a number of different places, but in particular in factor 10, they talk about dev prod parity and how important it is to sort of mirror your production environment as realistically and as closely as you can in your dev environment. This long-winded way of saying, don't take shortcuts with this stuff because it undermines all the other hard work that you've done. And then practice number 9, make it easy for anyone to get the latest executable. This is where we start to come full circle now. We're getting back to some of the communication stuff that we alluded to earlier on. And in this case, the latest executable, if you're doing like a web app, you could think of like a stage or a demo environment. That would be like the best analogy, I think. But what you're really doing here is expanding your feedback loop. You're casting a wider net. I'm just going to read the quote from Martin Fowler here. We found that it's very hard to specify what you want in advance and be correct. People find it much easier to see something that's not quite right and say how it needs to be changed. And that's definitely true for me. And that really fits with that sort of agile development methodology that we talked about earlier, that iterative approach to things where you like kind of slowly dial in on what the customer really wants. So having a demo environment or an intranet download site where anyone involved with the project can take the latest binary for a spin and try it out, having that sort of like openness by its very nature invites further feedback. It invites opportunities for possible course corrections that could help us get closer to what we really want to achieve. And in practice number 10, we sort of take that same idea and kind of expand on it a little bit, where Fowler says everyone can see what's happening. And I just have a quote from the Agile Software Manifesto in the top right there. Core value number 1, individuals and interactions over processes and tools. So how do we solve the synchronization problem? We talked about this in like slide 3 or 4. We use communication. We leverage communication to stop, big, massive changes from bogging everyone down. We create streams of information instead. We want to consume, we want to watch the Netflix of other people's code. We don't want to like binge watch every episode of something. We don't want to get dumped on with tons of information. We want something that we can consume at a manageable pace. We can expand this to dashboarding. If you think about any of these tools, you might not like their UIs, but GitHub has their workflows. You've got Jenkins, Circle CI, GitLab, Bitbucket. They've all put substantive work into trying to make their dashboards consumable. They've all put substantive work into integrations with things like Slack, email, whatever. They're trying to get the word out. They're trying to make it so the team can respond faster to broken builds. So the team can exchange information with each other faster. So you've got a place you can go to get notified on what's happening. And you can kind of, if you're an outsider to the team, you can see progress being made too, right? So you've got, the build automation as a potential source for monitoring. And then I think this trickles over into like Jira, Trello, any sort of Kanban thing too. You want monitoring for your project's progress as well. You want to make that digestible as well. If you have all of that, readily consumable, and there's no like, well, I don't want you to, there's no like secrets or whatever. There's no like silos, as they like to say in DevOps. There's no walls that are going up protecting this information. If everyone can see it, then you've kind of cured the synchronization problem by turning everything into like consumable streams of information. So we're actually ready to ship software at this point. I'm just going to quickly recap what we did. So we followed the first 10 steps that Martin Fowler has sort of like identified for us. I saw the question here in the Slack. I'm very tempted to react to that, but I'm gonna hold off on a little bit. But we took our code base and we included everything that we needed to build the project. We really thought things through. We thought about the language level requirements. So every library that we need, our package.json file, and we also included all the OS level dependencies, which is the less obvious stuff that we need and is just as important. We then automated our build. We probably wrote like a script as like a first draft, or maybe we sat down and wrote some YAML and actually configured our pipeline tool, but we achieved the automation that we needed, that we set ourselves up for. We then made our build self-testing. We wrote a bunch of software tests and we built some confidence in what we have to ship. And when our tests pass now, it actually means something. And we have this like concept of a validated build. We're merging our code continually. We're frequently merging. We're not waiting until we've got huge change sets that we have to cobble together. We've got small little pieces of changes that are easily consumable. Again, like thinking more like streams of information rather than big, huge swaths of it. Every time we make a commit, we build the project. We create a feedback loop. We want to get that validated build that tells us if we're on the right path or not. When something breaks, we fix it right away. We don't want to take that feedback loop around. We want to make sure we're continually moving away from integration hell. We don't want to fly blind and potentially be moving back towards it. Our builds are fast. We optimized for speed. We're testing in a clone of the production environment. We're not throwing away all the effort that we've made so far in introducing unknowns. We've made our executable or website available for everybody to see. and we're inviting feedback from everyone now. And we've embraced open communication and transparency of information to prevent the synchronization problem. So we're in a really good spot to talk about continuous deployment, continuous delivery. We're in a good spot to talk about CD. The denotation of CD is just as dry and as uninteresting as merging code continually, deploying or delivering software continually. If you were to Google these terms, you would find, I have like a little cartoony graphic here. You would find this same like image in some form. You would find it on AWS white papers. You would find it on Atlassian blogs. You would find it on the personal homepage of every product manager out there. They all kind of say the same thing. In continuous delivery, there's a manual step involved, and in continuous deployment, it's the full shebang for automation. Everything is completely automated. There's no people involved in the loop at all. This is good. This is good from a high level, but I think this lacks a lot of detail. Let's see if we can dive a little bit deeper than just this infographic that we'll find everywhere. In practice number 11, Martin Fowler is telling us to automate our deployment. And continuous delivery and continuous deployment are both implementations of this practice. They both achieve it. Just like integration hell, deployments are scary. They're terrifying, especially if you're an ops person. If you've got an ops team over here and you want to make like a massive change to the code base, like you're not making any friends. They don't want to get paged at 4 a.m. They're very adverse to that level of risk. Developers, on the other hand, have a totally different set of motivators, right? They're under the gun to get features out the door. They have, everyone sort of breathing down their neck, like, where is it? Is it ready? How do you bring these two forces together and stop them from colliding to actually cooperating? You tackle it the same way. You take that big, scary thing and you break it down into smaller pieces, and you just do it more often until it's routine. That's continuous delivery. That's continuous deployment. That's why it's continuous. Small streams of changes rather than big, huge, massive changes that like bury people in work that they can't get out of and are paging them constantly overnight when things aren't working according to plan. From a technical perspective, this is almost always a solved problem. You rarely have to write like extensive deployment software yourself. You think about all the major platforms out there. If I'm on GCP, I've got the App Engine CLI that I can use that's got all kinds of great automation. I've got Cloud Functions, I've got Cloud Run, I've got Lambda functions on AWS, I've got Elastic Beanstalk, which is kind of a one size fits all deployment solution. Say what you will about it, but it's pretty easy to get started with. You've got anything container based has got all kinds of automation now. Kubernetes, all of this kind of stuff. They all solve the problem of software deployment. And you've got all kinds of CLI tools out there. If you have to like roll your own server setup and you want to do like a code shuffle and then npm start or something, there's all kinds of CLI tools to do that as well. You don't need to write this stuff from scratch. That's not the hard part. The technical part is not the hard part. And in fact, going even further, in the article, Martin Fowler reminds us that continuous integration requires multiple environments. Like, remember, I talked about environment variables. I talked about it for like way too much at the beginning of this talk. Why did I emphasize it so much? Well, it's so important to keep your code base portable, and you need it because you need to deploy your code to your development machine, to your all your colleagues' development machines. You need to deploy it to the CI environment multiple times a day. You need to deploy it to the staging environment. We have already automated the deployment process. We've already done it. It's super anticlimactic, but it's been done. The technical challenge is already solved. Figuring out the process is what's difficult. It's the process that's tough. And that is the purview of release engineering, or relang. This is risk management for your continuous delivery, continuous deployment, whatever you want to call it. This is a often misunderstood or mysterious sort of discipline. And if you don't know anything about this, or these terms are new to you, a great starting resource to get oriented is Google has an SRE book. I'm trying to remember the title of it. The original one, the first one that came out, and it's like a collection of essays about site reliability. And there's a chapter in there on release engineering. And I'm not advocating that Google's solution for this is what everybody should do, but from understanding the problem and understanding the concepts, it's a pretty good starting point to like kind of delve into this kind of stuff. From a very high level, this is like solving things like how do you mark your code base to determine what a release is? Like maybe you use Git tags and you tag a commit, and that commit is what you're gonna deploy to a server. So you could use tags. You could use release branches. That's like another popular approach. So you cut a branch out of a particular commit, and now that branch represents what's running in production. So you have some sort of way of marking the code base to determine what a release is. And then are you going to do continuous delivery, or are you going to do continuous deployment? Like what's the better fit? And is it a permanent decision, or is it just like a temporary one? You want some flexibility in whatever process you come up with, so you can do potentially both if you have to. What are the technical tools you're going to use? Well, probably you have like some sort of systems constraints that are in place where they've chosen, we're going to use Firebase to deploy the front end code. So probably, that decision is made for you and it's not such a big thing. But in other environments, it's a little bit more nebulous, and you have to weigh the pros and cons of each. And then maybe most importantly, how are you going to measure success of a deployment? And how are you going to roll back if things go bad? You need to think all this through ahead of time. That whole notion of what I talked about earlier, where your deployment process was SSH to a server, clone the code base, build it, hope it works, and then start it, starts to look pretty pale in comparison to something that these guys might think through. Now, in terms of like selecting continuous delivery or continuous deployment, it's probably business constraints or technical constraints that would force you to make that decision. And they could be permanent constraints, or they could be temporary ones. Go, no go meetings are a good example of business constraints. You might have a new customer and they're really sensitive, and they're a lot of money for the company, so that you're really treating them with kid gloves. And for the next few sprints, they're going to personally look at the stage environment before any major changes. So that you're doing continuous delivery now, and that's forced on you by the business constraint. It's not a permanent scenario, because probably they'll develop some comfort with you guys at some point and you can go back to business as usual. But for right now, you're doing continuous delivery. On the other hand, you might have like some super careful CTO who wants to personally inspect every deploy, even if it's 10 times a day. Sounds super far-fetched, but that would be a silly example of a business constraint that forces you to use continuous delivery all the time. From a technical constraint perspective, you might have something that involves downtime. So maybe you're changing database providers, or you're doing like a massive database migration that's going to set you up for something down the road. But some sort of like technical challenge that you can't serve traffic while you're doing this particular deploy. So you're opting for continuous delivery in this model, and you're probably going to have to inform your users ahead of time and manage that whole process as well. So you definitely want flexibility with whatever process you've set up. If you are doing continuous deployment, what's really popular now is to add like additional layers of risk management. Like all this stuff is risk management. How do you take that scary deploy and make it into something that's less scary for everyone? So there's two strategies for that like additional layer of risk management that have come out right now, or that are like widely available right now. The first is canary deploys. This is like in shops where maybe you have, let's say it's like medium size, you have 5 servers that are serving traffic to customers, and you're going to deploy, we're going to do a canary deploy. That means we're going to deploy to one of them. So we have 4 servers that are still serving the old code and 1 server that's serving the new code. So you have like risk management there, right? If something wrong with the new code base, that's no problem. We have 4 other servers there that are still doing, the same old thing, and we're not going to proceed any further if there's an issue. But we also get this opportunity to watch how a small subset of users actually interact with those features that we just put out the door. And we can get some like early feedback to the development team, and particularly the product manager would be probably very excited to kind of get involved with this, right? But that's a canary deploy. You minimize the risk by just changing a little bit of your infrastructure. And as you can kind of figure out, it is sort of infrastructure based. Like this is built into the fabric of all of these offerings from the major cloud vendors, and there's tons of tools that do this, even if you're not on the cloud. But examples would be like App Engine does this kind of traffic shaping. Kubernetes does this. You can do this with DNS, so you can pretty much do it with like any, Route 53 does this out of the gate on AWS. You can pretty much do it with any kind of solution at that point, but you need a little bit of infrastructure expertise to pull it off. So that's sort of like, that's the pros and cons of canary deploys. There's an alternative that's a little bit newer. It's called feature toggles. And this is where you put the new feature that your team developed behind like an if statement. And you have a third-party service that you subscribe to, and you can selectively go into the console of that third-party service and hit a button and enable or disable that feature. So you achieve the same thing. You can allow a subset of users to interact with the code on a as needed basis and get some like feedback as to how successful was the deploy. Did enabling that feature hurt anything else? Did our error rates go up? And you can also get some like concrete, usage data to give to the dev team, in particular the product people, as they would really, really value that. So that's release engineering from a very high level, and that's Martin Fowler's 11 practices. And that's pretty much the bulk of what we were going to talk about. But I added 2 bonus topics. This is like a five-minute add-on if you guys are okay with it. It's just a little bit about pipelines as code, and then a little bit about continuous security, just because it's just incredibly relevant, and it's not a whole lot of extra discussion to get kind of a handle on it at this point. And I'm just going to go ahead. So bonus number 1, pipelines as code. So the idea here is that you need to configure your integration with whatever tool you're using, right? And I think this concept you guys are probably all familiar with. You've got those, little workflow files that sit in your GitHub folder. You've got like maybe a Groovy file that sits or a Jenkins file if you're using Jenkins, and various config files for all of these third-party tools, and they're all different. Like from a high-level perspective, they all allow you to tweak the same knobs and allow you to achieve the same things. You configure all your integrations. What Slack channel am I sending messages to? What email address am I sending messages to? What are the steps in my build? And then what steps are concurrent, which is definitely of interest. And then, how am I handling things like environment variables? And this is different for every vendor, but again, from a high level, they all work the same way. I just call out environment variables here because one of the things that you really want to think about with environment variables, just like they often contain like the number 1 most sensitive things that your code base is handling. And this is often like, the production passwords will pass through this avenue, the production API keys, maybe other sensitive material that you just don't want to broadcast to the wider world. You want just you want to be sure you know how your CI tools logging works with environment variables. You wouldn't want to leak something here and then have it get, possibly digested by the wrong person who's like 2 days away from leaving the company or something. I know it sounds a little paranoid, but it's better to be safe than sorry with that kind of thing. And then another call out again, shell scripting is just so key. I really recommend, like, if you're not a shell person, just spending like an afternoon and getting familiar with it, particularly with how to manipulate environment variables in shell. Any confidence you have with like bash or shell scripting will take you a very long way with pipelines. I think bash will be around in 10 years. I'm not sure I can say that about fish shell. I do like fish shell. I'm not knocking it or anything. I just think there's something to be said for like your bread and butter Unix basics, and they've been around for a long time already. I don't see them going anywhere, but definitely run that past somebody like senior in your own circle and sort of validate that idea. But building on this, so now that we've got like that foundation built, we can talk about kind of a more recent development with pipelines as code. And that's the appearance of these sort of reusable pieces of like off-the-shelf parts for your pipeline. I think that says it best. You now have third-party modules, just like JavaScript libraries, but you now have that for your pipelines, and they kind of all do this now. Like Jenkins, you've got Groovy files from, community sourced Groovy files that you can use. GitHub Workflows has this actions thing, which is incredibly easy to use. Circle CI has orbs. GitLab allows you to like build containers ahead of time and do the same thing. And Bitbucket has pipes. Why is this a good thing? Well, you don't have to write, you don't have to write the code yourself. Instead of writing like 100 lines of bash, you can just like string together calls to these third-party modules and kind of assemble your pipeline that way. You'll still need some bash to kind of glue things together and probably to finesse the environment variables. But aside from that, it's pretty nice to be able to use somebody else's code. The main motivator for this is that bash is very hard to test. Shell scripts are very hard to test. If you can use like a higher level language, that's great. If you can use a module that's like that does one thing very well and is tested, like it has its own pipeline or whatever, if you can use that third-party module that is extremely reliable, that's like the best. Now I can cobble together my pipeline out of pre-built pieces of pipe and save myself a bunch of time. But I wouldn't go using anybody's third-party module. All the same rules that all the same rules that apply when you're vetting like a JavaScript library, all those same rules apply to this. If they're not testing what they write, you might be tempted to write it yourself. If they're not doing CI/CD inside their code base where they're developing this module, it doesn't sound too good either. You want to wear like your critical thinking hat, and you shouldn't be afraid of like writing it yourself if you need to, or writing it yourself in a higher level language. You could write it in JavaScript, you could write it in Python, you could write your own test suite for it. So that's pipelines as code modules. And then lastly, I just wanted to touch on continuous security as well. And that's just because of like all the attention this topic gets now. If you've got Pi that gets leaked by a company, it's very embarrassing, but there can also be financial implications for getting hacked or something. So continuous security is this idea of embedding security into your pipeline, and it's relatively new. It's not in Fowler's article, it's something that came along much later. But we talked about this already with that idea of like a cron build that would periodically run npm audit in a pipeline and check your dependencies to see if there's any vulnerabilities. And somebody mentioned SNCC, which is a good tool as well. And you've got Dependabot. There's a myriad of tools available to do this, but they all kind of derive from this concept of integrating continual code base monitoring, which is what continuous integration pulls off by the way of building every commit. You get this monitoring for your code base. You want to include a security aspect to that. So however you achieve that, You just want to make security present in your pipeline to some degree. Another sort of great low-hanging fruit you can tackle is looking for credentials that got checked into the code base accidentally, and everybody's done that. Passwords, AWS credentials, whatever. But there's tools that you can get now that integrate with your CI that check for this stuff. Git leaks is a good open source example. Microsoft has CredScan, and I think there's probably a million other ones. But you just run a step in your pipeline that looks for this. And if there's anything present, you stop the pipeline and you alert everyone that there's a problem. And you take care of it right away, right? Because you're following all the other practices that Fowler advised us about, 15 years ago or whatever. There's other static analysis tools that you might want to use. I'm less familiar with the JavaScript ecosystem for this. I wrote down here Bandit for Python because I know that library and it's pretty useful. It does like checks of your system calls to make sure that they can't be abused in some weird way. And that's kind of cool. But anything else that you can like run on a periodic basis to kind of keep an eye on the health of your code base from a security perspective is really great. You may have heard of like, there's a lot of like buzzwordy terms that go around out there, but there's this term like shift left. You might have heard of this. And there's this idea, it's this idea of like shifting security away from the sort of last minute integration hell type scenario to earlier stages of the SDLC, where you catch it in your pipeline way before it ever becomes like, front page news or whatever. That's the, drastic end of the world scenario, but you get what I mean. You want to shift it left in terms of its appearance in your team's ability to assess it and react to it. So now your builds fail whenever there's a security threat present, and you can do something about it before it's too late. So that's continuous security at a really high level. And that's my talk for you guys. I hope there is value there. I really hope that it helps the next time you sit down and you're like need to tackle one of these pipelines, because they are, they do require like a large breadth in terms of like what you need to sort of consider as a potential problem or a potential factor that could sort of lead your team astray. The sources are there on the top right, and I think as Jen and Matt said, the slides are available in the Slack channel as well. And I'm happy to answer any questions or whatever that people have. And if you're not a talker, I'm also happy to respond to emails.
Thank you so much for that talk. I feel like we went through a history of ideas in a way that kind of trace up to the present for really these ideas that underline, I guess, like agile software development. And then there also being, I guess, like new tools and new third-party integrations that kind of have made our lives and then also just the implementation much easier. It's almost like for granted now, or like my, first to reach for kind of options were the ones I just listed, at first Heroku, Zate, or Vercel and Netlify before I really like looked into like actually how do I build a pipeline and make sure that, the process works for testing software and ensuring that it's like at first, unit tested, then the integration tests run, and like, yeah, the security of the dependencies are checked for and all of that. And it's very layered, I find, in a very kind of systematic way of thinking about how software should live like out there. Just wanted to roll back to a question that we had from Rajat earlier here, or if Rajat, you want to like ask yourself.
Sure. Thanks, Niall. This was great presentation. So I had the question like, which is your, like there is GitHub Action, there is Jenkins, there's Circle CI, there is one through GitLab. Which is your most preferred And which is the one which you had most frustration with, maybe outside this list, but was just curious.
Sure. I answer the question, but I'm at the same time, I like want to sound a note of caution in that I think like, for me, like, I don't want to understate how much getting this additional context even helped me after having, written X amount of number of pipelines already. There were some things that I dug up through the process of researching this that I was like, oh, that's why it's that way. And those kind of little aha moments really changed the way that I think about a lot of this stuff. In terms of like selecting a tool, I think you're bound by some constraints off the bat. So I could tell you what my favorite one is, but I could also say that you have business constraints that might opt you to choose for one or the other, right? Like if you're in a really guarded financial sort of like fintech sort of scenario where you've got a really sensitive security aspect to what you're doing, you might want to look for, you might narrow your list of options by only looking for ones that you can host yourself and host behind, a controlled environment. So I'm just flagging these things as like sort of upfront factors that might influence your decision, right? So, and I think at this point they pretty much all do. But again, you never know what kind of like weird tricks security folks might throw at you for compliance reasons, and they're not being evil. I think they're trying to help you. But in terms of like my own personal preference, I have recently gotten really excited about the sheer number of people who've been working on GitHub Actions, and just the wide variety of like cool off-the-shelf solutions you can get for a lot of things now that were, that I've also had to cobble together myself. And I just really appreciated the fact that, I don't know, I can just do with, with Firebase rather than like building a container that's running Firebase and doing all of that. I like that aspect of it. But like I said, like they all have their own implementation of that now. So it's just, I think the community behind GitHub Actions is just very big. Microsoft's done a good job, I think, of like tapping into that and promoting this product. So I think that's having a little bit of a heyday right now, I guess.
Cool, thanks.
If there are any questions, feel free to raise your hand. I have one that I really like to ask of anyone working with CI/CD and DevOps. How do you test a pipeline? I remember, you mentioned like duplicating or making a clone of that production environment. Moral of the story being don't test on prod. As I guess like I have with a lot of my personal projects, but then soon realize that when I'm doing that for work, I'm like trying to either duplicate or create a separate branch with like the YAML file in it, and then running it, checking it works. But then really the only way to ensure that it works on main or master is if I merge it with master and then, see that it works. So what other kinds of ways? I imagine like, creating that separate but duplicated environment with like the exact same things at a particular state or at a particular commits contents, and then running it. But yeah, what do you think?
I don't want to be the only one to answer because someone out there might have like a great idea, but I do have like one little trick that I found useful for that kind of thing, but it's a little bit of advanced work, and that's to use templating. So the code base contents might change. So there may be like some particulars about, what you're doing that might change, but maybe it's a React app with, certain libraries present, and that forms enough of a common basis that you can create a template So you can create, rather than like these modules are like off the shelf pieces of individual steps that you can cobble together to make a pipeline, you can create a template that is a pre-existing pipeline that cobbles together more steps into a longer section. So this would be a template that contains maybe 10 steps that are common to any React project or common to any Angular project. And that can form the basis of a template that you can run with some stand-in pseudocode that's just like a placeholder for an actual code base. And now you can set up a pipeline for your template, and you can actually test that section of pipeline end to end, with the code base being essentially your mock, like you have a mock code base for your pipeline. That's incredibly time consuming to set up. But once you've got that in place, now you can just bang off copies of that template for any React app that fits that sort of specification. So that's just one idea.
That is super interesting, because I really never thought about like code as mock code to test a pipeline. But yeah, when you mentioned templating, like in what form or what way, like, is that like a YAML file or like a config?
So I'm a more of a Python person, to be honest, than a JavaScript one. So I know that there's a lot of great templating engines in JavaScript. I just happen to know Cookie Cutter better because it's I guess because it's Python based, and I really cut my web development teeth on Django. So I've just been working with it for a long time. But so Cookie Cutter just uses this sort of like idea of there being variables that you prompt for at the beginning of the templating process, and then you just do superstition, interpolation of those values into what you generate. And I found that it's just like a really good platform for this. I actually have I have a couple of projects that I could share if people are interested that are sort of like implementations of this. But again, the idea is just to find like what are the common, like if you have a, if you're doing a number of projects that are going to be the same way, extrapolate a section of pipeline that you think is going to be common to all of them, and then just find some way to template that section of pipeline. And then you just need, like you said, a mock code base to test it under different scenarios.
That's great. I'm going to look into that. Cookie Cutter templates in Python. All right. It seems like there is a question from Paresh. Paresh, are you there?
Yes, I'm here.
Hey.
Hi, Paresh.
First of all, thank you guys for this amazing presentation. I really appreciate the same. The other thing that the questions that I have, so I'm completely new to Circle CI, and the questions that I have, you said that it's YAML is preferable over shell script. So what's the exact, because in shell script also we write the same commands that, okay, git clone, then cd to the application directory, npm install, and then run and build. So what's the exact difference between YAML and shell script? How does it differ in terms of implementation?
Well, I mean, I think from the high level perspective, just defining the steps that you have to do, there's probably not that much difference. Like you are going to have to find some way to clone the code base. So that's probably going to be a shell command, unless you can find like, you have to pardon me, I'm not an expert on Circle CI, but they have that orb concept where you can sort of find pre-built modules that do some of this work. So you might have like a git clone orb that you could use, and then you could just configure that in YAML without writing any like bash commands that could possibly go astray. So you have that option available to you with YAML. But I think the real extension that Pack or Pipelines as Code extends to you over like raw shell scripts is it requires you to define the things like your integrations with, like, you have the ability to capture in your code base things like what Slack channel are you propagating messages to, or provides you an avenue for setting that up, as well as like taking advantage of the CI tools concurrency features so that you could potentially run multiple steps at the same time, so that you're not directly, following the 2-kilometer long train way of doing things when there's some like parallel avenues that might open up for the way that you're approaching things. So YAML sort of takes a sequential bash script, adds some parallelization to it, but allows you to go further and configure some of the other features that are available to your product. And it allows you to use those off-the-shelf parts to accomplish tasks that you might end up scripting yourself, but you might go and find like, oh, there's a publicly available module that does this, that runs Firebase for me, and I can just use that orb instead of running Firebase commands manually myself and not having to worry about what version of Firebase to install all the time and keeping it up to date and stuff.
Okay, perfect. So I got the difference, and so the packages that are available that might be useful in YAML rather than shell script, we have to specify some version or anything. So I got the difference. The other question I was having is you said that means while there are lots of steps to deploy an application, for example, you said npm the cloning of code base, npm install, that is installing dependency, run or test, and then build. So in one of the screens there were three parts. So that were having running the common steps in all the three steps or cloning the code base. In the first script it might be npm install, in the second script it might be npm test, and in the third script it says that npm build. So you said that this can be run in parallel rather than waiting for each and every command to be executed synchronizationally. So the question is, if we run this in parallel, what if the dependencies are not being installed?
I'm trying to imagine the scenario that you're thinking of here. So the concurrency doesn't always work the same way.
Okay.
Like for example, you can mix and well, first of all, you can mix and match between sequential pieces of pipeline and parallel pieces of pipeline. So you can all of these tools have that allotment. So you can define a certain series of steps that has to happen sequentially. And then you can also say, but at this point, I want these 3 steps to be dependent steps that run in parallel. And then finally, there would probably be like a sequential step at the end that waits for everything to finish. But that is all handled at the YAML level. There's all YAML configuration that allows you to sort of orchestrate that parallelization. But you can also do that in Bash, right? You can run background tasks in Bash. If you really want to do it, you could run like npm test ampersand and get the PID and check the exit code at the end. You could do that in Bash if you wanted to too, but I wouldn't recommend it.
Okay. And I think the last question, maybe you said that there are 2 types of deployment, or means CD, means continuous delivery and continuous deployment. So that has a difference, that continuous delivery has a human interaction and continuous deployment may be automated. So while automating it, so the only means thing that I cannot get is like means if we write an YAML file while we are cloning the code base, so in that it is pre-assumed that we have that GitHub logged in into our terminal or into our AWS EC2 instance where the cloning will be done through that YAML script. So means how does that works in the automated part or the continuous deployment part? Do we need to give credential at some place? I'm just asking because I'm totally new. If this question sounds stupid, just forgive me.
No, you're not. You shouldn't refer to yourself that way. You shouldn't make tracks like that. None of us are stupid. The questions you're asking are very challenging, but there's not a one size fits all answer to that kind of thing. And I think it all depends on what you're trying to pull off. And it can all be it can be tough to figure out like how to do all this and keep it secure too, because you don't want to like leak credentials all over the place. And again, you want to leverage environment variables to use all this stuff. But you want to, I think the best thing to do in this sort of case is to look for opportunities to break. Like you want to be able to separate your build process from your deployment process. Like for example, I don't know Circle CI as well as I do GitHub. So I'm going to use GitHub as an example, but I'm sure there's something relatable back to Circle CI that you can take advantage of. But for example, GitHub allows you, any of these tools actually allow you to like make decisions that are different based off the presence of a tag or a branch name. So you could have forking behavior in your pipeline that deals with tags differently than branches. So that's one way to get like a different set of behavior. But in GitHub Actions, you can GitHub workflows, you can actually respond to different events. Like you can have push events that you respond to, and you would have run a certain workflow for that. But you can also have like events that respond to like a release being created in the console, and once somebody's created a release at a certain commit, it triggers some automation that picks up from there. I know Circle CI has this thing where they integrate approval windows into the workflow itself. So you can set up your pipeline so that they'll send out emails and then require people to like confirm yes or no. Amazon does this too with like what's it called, code build or whatever. There's lots of implementations for this, but the tough part I think is like slogging it out and really going back to the documentation and finding out like what avenues are available to you to sort of mix up the different types of automation that you can do. Like, do you have to use if statements and do branching logic? Or do you have to use different triggers that come from different parts of the SDLC, like from when somebody creates a release in GitHub that, create a webhook that pushes an event and then you do something with that. Some way to respond to different events would be another way to handle that. And then another way to tackle the same problem would be to, I have no clue what I was just going to say. I'm sorry, I totally dropped what I was thinking there, but being able to fork the behavior of your, use different sections of logic to respond to different events is kind of, I was going to talk about the approvals, is a way to like split up that. So it isn't such a like, again, if you can stay away from one big file that's doing everything and carve that problem down into smaller files that do like certain parts of it, that's way easier to deal with. Although they still haven't figured out like an import solution for YAML, which would be really cool. Anyways, I don't know if that helps at all, but just.
Yeah, but this whole presentation helped a lot because I have been here first time and very new to this concept. So yeah, the questions that you answered are definitely helpful. Thank you so much for that.
And yeah, you definitely want to check out that feature of Circle CI though that lets you do like set up manual intervention steps. I can't remember what it's called, but I remember reading about it. It's really nice to be able to add that flexibility that lets you choose between continuous deployment and continuous delivery whenever you need to sort of mix it up.
Yeah, for sure. I'll look into that.
We have any other questions from the audience? Another thing I was wondering actually, and as I went through this very slow moving gradient of learning CI/CD based on the tools or the enterprise tools that are given to me at work, I'm wondering if there's any kind of resource or book I could look to understand pipeline patterns, because everything's been very kind of linear for me, like install everything first, lint it, then test it. And then of course, like the notion of parallel kind of operations comes up, like maybe index everything, make sure everything's in the database before I, do this other thing. But it's been like so far, working, on the front end side and then being on very aggressive timelines. Most of the time, it's just being able to have, small commits, like you said, be like push to dev and then also like possibly QA in production. Sometimes timelines are so tight that you really only have enough time or like enough people to maintain one pipeline, and there might not even be multiple environments. And yeah, sometimes that there's like, differing, I guess, like pressures. Like sometimes if you work with like more enterprisey type clients, then they might want like, your typical prod, QA, dev, UAT, staging, however many environments. But then you're working on a project that is like basically proof of concept building towards MVP. How do you like, what's your approach with like tackling that? Sorry, those are 2.5 very loaded questions, but yeah.
No, they're insightful. I mean, I'm not sure I have like a good catch-all answer to that myself. But I would certainly say that in terms of like achieving velocity, like again, I don't want to present myself as like some kind of DevOps expert, but the understanding that I have for the importance of velocity on a dev team is directly tied to the sort of level of automation that you've been able to achieve. And there's very much like, I don't want to make tools the be all end all of everything, but being able to spend some time on the pipeline so that you kind of get those kinks out can pay like dividends off in the long term. But not everybody sees that up front. And you want to be careful. You don't want to make like working on the pipeline to become like a pet project that bogs you down in a different way and becomes this other thing, or you're like, you don't have, the people around with the right expertise to pull it off in an expedited kind of way. But if you can get some of the kinks out, if you can like identify some low-hanging fruit and you can explain it to the decision makers in terms of like the value that it brings in the long term, I don't know, however you make that sales pitch, that I think that's a big part to like freeing yourself up to kind of tackle this stuff a little bit more. I don't know if I'm hitting the nail on the head there or not, but that's what comes to mind. And it can, I can think of different parts of my career where I didn't even know that trade-off really was as strong as I thought it was. And then I think it's only about having worked in a lot of different environments and seeing how much time some people put into the thought process and maintenance of that kind of stuff, and then how it's sort of more ad hoc other places, and then sort of realizing the benefits of it. It was only after kind of having that perspective that I really, I guess, was able to appreciate it. But I think it is like you kind of have to bring people around to understand the short-term pain and loss of in the apparent loss of productivity in the short term to the to opening yourselves up to like faster turnaround in the long term.
Probably also like to do with like the number of people on a team as well. Like having like pipeline that is carefully planned serves a lot more people. Like it helps well from dev to QA. And then even like, yeah, having a separate environment for your clients to do the UAT, for example, is a huge difference. But yeah, I guess the trade-off being made initially with like spending time on setting that up, and then hopefully not having like the bizarre kind of, for example, like recently, I think a lot of things that were turning a pipeline that I was working on red was to do with how Prettier ran in that environment. And none of those errors would show up locally. And I don't know, like I felt like it was very improper to not lint right after installing or building. And so it just like was orange or red for the longest time. And the lowest hanging fruit thing was actually to just like append the -- fix flag. And yeah, but yeah, there were some parts of that were unexplained or if anything, like dragging, I guess, or breaking more than expediting it to deploy. And yeah,
I mean,
it's like,
right when you say that, I think of things like just making sure that the config is present in the code base and that you're using the same config in both scenarios, and just keeping your CI environment as closely aligned with development. But I also think of not getting too bogged down in the weeds and keeping your eyes on the real problem that you're trying to solve. And like one of the reasons we use Prettier is to avoid white space becoming a problem with PRs and code reviews. And you know, if I don't know, I do this all the time. Like you get sucked into a problem, and solving the problem almost ends up becoming the goal in some respects. And I'm not suggesting at all that this is what happened with you at all. It's just what it's just echoing some things that I've learned. And yeah, just keeping your eyes on the right prize, I guess, is like one of the things that helps you through those moments, I guess, or it helps me anyways.
Yeah, that's a really great way of looking at it. I'm also, yeah, to go back to one of my initial, I guess, like comments / questions, I'm wondering if you've come across any resources or books that inform, like, you know, an idea around like pipeline or CI architecture.
I'm sorry, I don't have anything off the top of my head to recommend in that space, but your question's a good one. I want to kind of I want to think about that, and yeah, I want to give that some thought and ask around about that myself. It's a good question.
Yeah, I think I don't really, I haven't come across that myself, but it's probably also like my own echo chamber with like being front end oriented. But most of the time, like, yeah, it's usually when a new developer comes on board and they look at like what's there, that I get some kind of reflection on like how to improve it, or the norms that are apparent to them, like, oh yeah, like this is going to automatically deploy to dev, and then there's going to be a trigger, like a manual trigger for going to QA. So only certain, you know, only certain commits that we want go to QA or whatever, or having like a separate, always being able to have like your particular PR commit be possibly previewed, if not deployed to its own separate like environment. And so those were some like things that came up recently, like for discussion from an enterprise kind of like client. So yeah, it's like degrees of granularity, like how much do we want to be able to isolate and test that particular thing vis-a-vis how important it is to the project. But yeah, so that kind of spurred me to think of like, oh, like, you know, are there patterns around this that I haven't known about? Because like the whole like even idea of like software architecture, you know, as like a thing to get into, or solution architecture as a thing to get into beyond just senior development or whatever, has been quite new to me. But yeah, something to, I guess, like poke around for, or if anyone knows, feel free to suggest in the general Slack channel. Are there any other questions? I know it's getting quite late and you've given us like so many nuggets. Yeah, got like 2 bonus slides. And also I feel like this is like a distillation of decades of experience of head banging while trying out very many different processes. And also actually, yeah, what you said about Bash and shell scripting, I am very surprised, but yeah, some of the like senior DevOps people I've worked with, they were able to just like accomplish everything by running shell scripts. But there are less people now who just use that day to day. It's really incredible how that still, you know, gets the job done. And yeah, if there were something else I could have learned, I guess, like instead of just focusing on dev, I think like, or I mean, just focusing on front end, I think like Bash is like super powerful.
It's crazy how much you can pick up in an afternoon though. Like it's very terse, it's very hard to read, and and people can write it so it's like totally indecipherable if they want to, but It also provides you with some like really handy ways to just quickly change things without having to install a bunch of software to get something done. But you can also write JavaScript and write tests for it and have something that's like better and more maintainable. So
I think also the idea of being able to split things up into separate scripts or separate like sequences to run has always been something I really liked as part of like the tools or CI tools I preferred. Being able to integrate outwards, like with existing like third-party software. I think that's what like makes me want to gravitate towards existing third-party vendors, where it's like, okay, yeah, I've signed in with GitHub, selected the repo I need to, with the code I need to deploy. So hurrah, it's done now. Committed, and now it's like now building, don't have to think about it. But yeah, I imagine there's something that's a lot more, I guess, extensible and I almost view it as more ambitious of not like there's more control, I guess, with being able to write your own scripts.
I think everything's got its pros and cons. So like, yeah, scripting, you're right. You can do some like really miraculous things with it. It's also crazy hard to test. So you better hope that that thing that you wrote works reliably. So, you know, sometimes things don't go, sometimes that shortcut you took isn't such a great shortcut. It can depend. But in terms of like YAML and its trade-offs, well, I mean, the gentleman asked about the differences between writing scripts and YAML. And one of the big downsides that I see to YAML is that you can't inherit from other YAML files, but you can do that. You can source bash scripts. So bash for the win there. But I mean, it's even better in a higher level language, right? But that idea of like what you said about being able to break things down, that's one of my personal frustrations with a lot of these tools is you can't do any sort of like inheritance between configuration files.
So then you just run a really, really, really long aliased sequence.
I like to use short scripts to do clusters of tasks together, and then I like to template that stuff so that I always kind of use scripts that I know work when I'm doing that kind of thing. So I like very much try to find commonalities between the like pipelines are rarely a one-off thing. A lot of what you do, that same series of steps, you know, npm install, npm run test, npm audit, that same series of steps you probably use in a lot of different code bases. So identifying like those common pieces of pipeline, which I'm not sure, I think that just comes from having worked on a few different projects, like worked on pipelines for a few different projects. But once you can start sort of spotting those commonalities and start applying like, you know, basic principles of refactoring that, you know, you guys probably all do better than me, you'd be able to extrapolate from, you know, pieces of scripts that you can sort of reuse and start to get into the templating stuff and the reusability stuff.
Right, I meant like with a YAML file though, then you're just basically like stuck with a really, really, really long YAML file, or
What? No, like what I meant was you can refer to scripts in your YAML file. So you could
Right.
have in your code base checked in a few scripts that do like common tasks.
Mm-hmm.
And then you could load those scripts in your YAML file as a way to sort of like get around the problem and try and like use the inheritance features of bash when you can to sort of save yourself from having to write like huge YAML files. But those would have to be pretty complex pipelines, I guess, for that to be a problem.
Right, that makes sense. I guess as long as it's all in the same environment that it's running in.
Yeah, and like it's in the code base, so it's accessible. And then one of the nice things about scripts too is if you ever have to change vendors, you've got something there that's common, right? So I definitely think bash is going to be around for a while yet.
All right, so we are approaching the end of our, I guess, like Zoom session or the end of our activity. I'll give everyone 10, 20 seconds if anyone has any last questions. If not, Niall's also on our Slack channel. Their name is at NBYRNE.
That's right.
Yeah, you generally hang around the, I guess, like general and also React channels. Yeah, and we'll be sharing the slides and the recording. But this has just been like super wonderful. I think this is a topic that we don't cover as much here at Toronto JS, but everyone kind of talks and complains about it. So yeah, I think that like it's just such an exciting area, Billy. And just like, yeah, bizarre how like, yeah, there's like just infinite solutions for doing exactly the same thing.
I think we have one more question from Paresh before we wrap up here. If
Oh,
we
yeah.
can squeeze it in.
Yeah, feel free to ask.
Shall I?
We can hear you, Paresh.
Yeah.
Okay. Sorry, this question might not be related to Circle CI, but just the last question is, I think that you may know React. So is there any website where the best platform where I can learn React?
Well, I don't know if I'm the right person to answer that. But do you want to take a stab at that, Jen?
Oh, learning React?
Yeah.
Oh my God, React, it is definitely one of the best documented frameworks with like with a great community around it.
Their docs are pretty good as a starting
The
point.
docs are pretty good, but I do find for some of the like, you know, the primary concepts, it gets it's a bit abbreviated, I find. Yeah, what Urvashi mentioned there's like some pretty good like intro courses on Coursera, Udemy, and Udacity, but I can also send you a bunch, like just off the top of my head. I know that like, you know, there's a lot of like online gurus and like, you know, rockstar devs. But I know that the West Boss courses have been pretty popular. Can't See Odds did one on like Epic React, and apparently like that's pretty awesome as like a refresher.
He's a good teacher. I would second that. His stuff is really fun.
Gods does some great stuff about testing, actually unit testing, and I think he was one of the people that worked on testing library for React, which is really like been touted, I guess, as one of like the testing libraries for front end unit testing. And I think like besides that, I'm like trying to, because I had to, for like a year and a half or 2 years, like I was just keeping up with React on the side because I was working on Angular. I'm really tempted to say that like there's a site called react.rocks that has like a whole bunch of like snippets and like, you know, examples of what people made. There's a Discord called React to Flux. Egghead.io is also amazing, really concise videos.
I bet if you ask this in the React channel in Slack, you would have answers for like reading material for like the next 5 years.
Yeah, I find is hit or miss because like sometimes that channel moves so fast. But yeah, there's also a really great site that breaks down React hooks. Let me see, React hooks. But yeah, like I don't know, like there's always a new JavaScript framework, right? It seems like it changes every 6 months of what like employers are looking for, but I really do enjoy the dev experience with React. So yeah, it is a great framework to learn. There's just like a really, you know, great community and great docs around it.
Yeah, for sure. There are lots of suggestions and thanks for your input as well. I'll look into each of them, and I just had a freelancing project related to React. I did it, but I was not knowing it. I learned React within 2 days from YouTube maybe, but I thought that it is really nice, and I was not sure from where to learn it perfectly. So I think your inputs are really helpful and I'll go through them.
Yeah, sure. And yeah, definitely like feel free to ask questions in like the help channel or the React channel. I think, yeah, that's where a lot of our members are. And yeah, I think actually most of Toronto JS like is mostly using React, if not like Angular and Vue. So yeah, definitely very passionate community on that. But
Perfect.
thanks for
Thank you
bringing
so
your
much.
questions as well.
Yeah, thanks for the help.
Thanks. Well, we've had Niall talking almost nonstop for an hour and a half. But this was wonderful. I almost wish that like you were at our AMA tables, although you very humbly refused and facilitated. This was a Ask Me Anything event that I organized for a JS Code Club some months ago. But yeah, just to remind everyone, if you all are interested in or thinking about giving a talk, running a workshop, or even doing a reading group during any of our events, we're totally open to, you know, helping you run that or helping you run a roundtable if you have some role models or people you'd like to moderate discussion about. We'd like to hear about that. You could go to tinyurl.com/TorontoJS to tell us about that talk, or you can just message me or Miho on Slack. If not, organizers@torontojs.com. But yeah, thanks for coming out and thank you for, yeah, joining us and staying to the end. Pretty sure you can reach Niall online and yeah, let us know if there's any comments or feedback about this. But yeah.
Thanks everyone for listening.